Hello, everybody. Let me know if you hear me, and also let me know if you are able to write in chat, because that's the single place you can ask the questions. You see me? Let's just give a few minutes for others to join, and let's start. Okay. So yeah, perfect. Thank you, Roma. Let's get started. So today we gonna talk about the HTTP2 and like what is this, like what's the protocol, what are the benefits of using HTTP2, and actually how to test it, how to create performance tests, what are kind of challenges you might face during this activity. Because I would say that it will probably go not so smooth as you expect, unfortunately. At least it was. Not smooth in my way. In my case. So let's start with me. So yeah, as I believe most of you you know about me. If you're new to our channel, then you're probably interested in performance testing somehow. So feel free to join our community in Telegram, also join our YouTube channel, and if you are interested in any events or trainings, then check out our website or just ping me in LinkedIn. So let's start with really basics. Generally, what is HTTP itself? So why do we use it? So generally, HTTP it's the protocol. So the protocol is a set of rules which client and server should be using to understand each other. So actually, your HTTP request should contain like the protocol. So it's kind of standard set of rules that you need to just obey. So your request should have like the protocol, methods, URI, body, headers, all this stuff. So I will, it's pretty trivial and you know this. But what is HTTP1, HTTP101, HTTP2, and HTTP3? Because mostly, at least I was not thinking too much about this like before, because I was not expecting that like HTTP2 is too popular, or even HTTP3 is popular. So there are some kind of current usages statistics for HTTP1, HTTP2, and HTTP3. So on this chart, you may see, so it's just open data from Cloudflare. So Cloudflare, it's a big CDN. So they have a lot of, like they are passing a lot of traffic through themselves, so they know pretty well kind of distribution of requests. And as you see here, the most popular one, unexpectedly, it's HTTP2. And you may say, oh, I didn't know that. I thought still HTTP1 is popular. And you are actually right, because this chart, it is showing like the total, like the all traffic passed through CDN, and most of traffic is actually some static assets like pictures, styles. Oh, actually resources which are stored on CDN itself. And most of CDNs and Cloudflare especially, they are serving this data using HTTP2. That's why a lot of traffic is kind of served using HTTP2. But if we check the API, like the actual API requests version, yes, you're right that around like 40, or even like 1 year ago, it was around 60% of traffic, it was still HTTP1. And like HTTP, like part of HTTP2 is pretty like big, I would say, even for API requests. But more than that, there are a lot of requests using even HTTP3. So they are like, it was just released, not so like long ago, but still, like almost 20% of all API requests sent served by HTTP3. So it's cool. So actually testing HTTP2, like maybe in a year or a few years, it might be even non-relevant. Small, like all just switch to HTTP3. So let's talk a little. So now you understand that actually even HTTP3 and HTTP2, they are pretty popular, and maybe even your project is using HTTP2, but you just like was not aware of it. So we will also talk about how to kind of identify which protocol are you using, and should you should you care about this HTTP2 testing at all, or maybe it is not relevant to your project at all. So let's overview some details, regarding like different versions itself. So some just really high level information regarding HTTP1. So it is text based. One important for us thing that HTTP1 is using single request per single connection. So HTTP1 in HTTP1 protocol, the browser is allowed actually to send only one request through single HTTP connection. Actually, in reality, browser, like they are allowed just to be more performant. They are allowed to open maximum 6 connections and actually send like 6 parallel requests per host. It's just like important mark here to like per host, because if there are some client-side optimizations, performance optimizations, which are possible, which you could do. For example, you can use resource sharding. So resource sharding, it's kind of when you're, for example, when you're using CDN, you can go in a way to, let's say, store your images on one host, like on one domain name, your scripts on another domain name. And if you are storing them on different hosts, you would be able to actually utilize not 6 connections, but 12. Or like if you store them on 3 different hosts, you would be able to send 18 requests in parallel. So it's called in sharding. So when request is processed through HTTP, you are not getting response. So it's kind of sequential behavior. You send request is processed on server, you receive response in this connection. When server is processing request, actually this TCP connection, which is used under the hood, it is just doing nothing. And that's kind of where it is not performance so much, because we are not utilizing the actual abilities of TCP connection. So actual TCP connection is able to do much more than just like send one request and one response back. And also, if you're using HTTP1, this single connection, it is pretty network latency dependent. So the slower you will have, like the bigger latency you have, the longer response time you will also utilize. What about HTTP2? So it is quite different from what HTTP1 is. So here, comparing to HTTP1, we are using only single TCP connection. So it doesn't matter, are you using sharding or are you using your static resources requests or dynamic API requests or any other calls. Everything is sent through single TCP connection. And actually, using this single TCP connection, you are generally utilizing the abilities, the possibilities of TCP connection itself, because it is just running as fast as possible. Why? Because you are trying to send all your requests in parallel. That is called multiplexing. So multiplexing, it allows you to send all the requests using this single connection, and they are sent not like one by one, but they are actually split into small chunks, and they are sent by this chunk. So actually, you are transferring all your files like at the same time. HTTP2 is secure by default, so I'm not sure you can even configure like the HTTP2 protocol, like HTTP, not HTTPS. Yeah, and probably it's not even possible. And except multiplexing, it's like one really important thing in HTTP2. We also like have streams. So actually, these streams, it's kind of piece which allows us to send these requests in parallel. So different thing, how client and server, they understand, let's say, this small chunk of request, where it is related to. So that's where streams kicks in. So each small like packet, TCP packet, it has the stream ID. So client and server, they understand where this small piece like relates to. Also, you can also, as a front-end developer, you can prioritize this streams priority, or like its importance for you. So some of them, they will be processed like first, some might be delayed. Actually, the same as it works for HTTP1, because there are also a lot of different possible optimizations, how to like defer some resources, how to make something more important, etc. And also comparing to HTTP, because we are actually splitting this in chunks and sending it through on TCP level, it is binary, so it is not text-based protocol. And also there are a few, so it's the major things that we need to know: multiplexing and streams. So that's the two main things we want to remember for our future testing, because it will be really important for us. And generally, it's single TCP. I'll have a picture just in one slide. So we have only single connection, and everything should be possible to send in parallel. So there are like few more pieces that might be important for you. So we can compress everything. So in HTTP, we are able to compress only like response data itself, because in headers in HTTP1 we are storing kind of important information related to where it goes and how it should be processed. In HTTP2, we have this stream ID identifier. So actually, even headers might be compressed. So it's pretty good because we can reduce amount of data that is processed, that is transferred through network. HTTP2 also allows you to use the server push. So server push example is like, let's say you send request, give me like main page HTML file. So your server might be configured in the next way. So if I receive get request for main page HTML, then do not wait until client will start requesting all these static assets like styles, pictures, fonts, and so on. You can just push all this data to it. That's how you can even more speed up the process of working, but it should be configured, because if it is misconfigured, then your server might push too much data or the wrong data, and like overload, like make it worse kind of. So it should be tested if you want to use it. And also, if you are working in kind of not stable network conditions, you also may face kind of degradations, or when HTTP2 might be slow, because if like one stream has some packet loss, so it means that some TCP packets, they are not arrived to server, and HTTP2, it is based on TCP, and TCP, it requires you to get the acknowledgement that packet was received. So it is pretty like, it's kind of fraud. TCP is guaranteeing you that all the packets, they were received, and if something was not received, it should be resent once again. So that's where we may have kind of problems, because if you have a big like packet loss percent, then your streams will be like waiting for each other to be processed. So keep it in mind. And also, it also might be slower. Let's say if you have, let's imagine you have the client, some proxy server, your web server, and your backend. So you have client and proxy connection using HTTP2, and proxy and backend in HTTP1. So it also might cause kind of extra overhead comparing to just HTTP2 protocol itself, because you will need to establish extra connection on this HTTP1 connection, and it also will be kind of limited of HTTP1 itself, because in HTTP2 we can send everything through single connection in parallel. HTTP1, again, it's still regular HTTP1, so we need to manage a lot of different connections. We also are able to send only one request at a time, and so on. And what is HTTP3? So HTTP3 is actually pretty, it's not kind of too new, but so it was kind of not in demo, but kind of in alpha or something like that version from 2020, if I'm not mistaken, but it was like finally published in 2022. And the major difference here, comparing HTTP2 and HTTP3. So HTTP3, its goal is to make like to kind of do not have the problems that HTTP2 has. And the major problem for HTTP2 is kind of possible slowness in unstable network with big packet loss. And that's where HTTP3 should work without problems, because HTTP3, it is using the protocol called QUIC. And this QUIC, it is based on UDP. And as you know, UDP is not guaranteeing you, like, it is not waiting for, and it is not expecting all the packages to be successfully received. If some were missed, okay, that's totally fine. So this packet loss, like, they in different streams, they should not be affecting each other. So that's kind of the cool benefit of it. But still, it is kind of companies just start using it. But like, for example, some big companies like Google, or even your static content, your cached content from CDNs, they also might be partially served by HTTP3. So actually, you may also see it even on your project. So, and one picture regarding this HTTP1 versus HTTP2, just to visualize it slightly. So you have a client, you have server. In HTTP1, you have 3 requests. Browser is able to open 3 connections, separate connections. You send a request, the request is processed, you got the response. The same for others. So they are sent actually in parallel, but if you'll have not 3 but 20 requests, then first 6 will be processed in parallel, then other 14 will be waiting until at least one of previous is processed. In HTTP2, you have single connection, like one big connection, where all your requests, they are sent in parallel using these streams. So actually, here it is like visualized as separate blocks, like stream 9, stream 7, stream 5, but you should kind of understand it in your head, like this single block, it's actually multiple blocks, because this picture will be split in the chunks, and like it will send like the first packet for this stream 9, the first packet for stream 7, and so on. So it will be like continuously sending these small pieces, and the same, like here, yeah, like on this in this response piece. So we send one piece for stream 5, and then for stream 7, and then again for stream 5, another part of this response. So that's kind of how it looks like, and it's really important for us. It turned out that it's really important for us to understand how it works, because generally HTTP2, unfortunately, so it is actually the first time then when something is not working so bad in JMeter plugin, and like I'm really happy I decided to verify that it works. So let's before we jump into JMeter stuff, let's just check, does HTTP2 really gives you this advantage compared to HTTP1? Because like in theory, yes, it should be like cool, right? But what's in reality? You can check this site, http2demo.io. So it shows you, actually it shows you 2 different blocks. So this left block, both blocks, they contain a picture with around 180 or something like that, these small squares. So each picture contains of a lot of different squares, and they are loaded. So they are kind of inlined in HTML. So they are loaded as a regular HTML page does. So how it works: browser sent request for HTML page, got response with HTML page, then parse this HTML and find all the required static assets that should be loaded for displaying this page. So in this case, it should load a lot of pictures, small pictures, small squares. And for HTTP1, it took 2.05 seconds. And if you click on this button, it will load the same thing, but using HTTP2. And in HTTP2, it took 0.6 seconds. So it's kind of faster. Yeah, it's different page load, because HTTP1 took 2.2, just different. I reloaded page 1 once again. It's 2.2 and 0.6. So pretty good, right? It's around 4 times faster. Cool. So we have some advantage even in this small case. So hope that on more complex pages, we will still have some advantage. But how it works in like from the network standpoint, because it's important to see that it's working not just fast, but also to understand like why it works fast. So is it working as expected? Because we know that we should have this with single connection, and we also need to have this multiplexing, ideally, right? So all requests should be sent in parallel and processed in parallel. So the top part, it is HTTP1. So I was not. It had 150 or no, even more. 160, yeah, around 180 requests in parallel. And as you see in HTTP1, it is kind of the regular HTTP waterfall that you that you usually see in your Chrome DevTools. Yes, we do not have we do not see it from the beginning, but just trust me that it is executed like with these batches with like with 6 parallel requests, and we have kind of waterfall that like for example, like 60th request is executed quite like after the first ones. And for HTTP2, it looks quite different. So it is all the requests we were able to start them in parallel here. And also like the processing time of each request, of each separate request, it is slower. So if you check for HTTP1, we have 36 millisecond, 32, 39 milliseconds. So it's around like 20 to 40 milliseconds for each request. In HTTP2 case, it is like 170, 120. So it's longer, but it's 120 milliseconds of parallel processing. So generally, it will take less time for us in total, right? If we check how fast all these 180 requests are processed, in generally, yes, separate requests takes longer, but they are processed in parallel. That's why the total load time is faster. That's how it works. And will they actually be processed and sent like we see on this picture, when everything is sent in parallel and processed in parallel, all the 180 resources? Actually, no. So HTTP2, it is not forcing client to kind of process everything in parallel or send everything in parallel. No, HTTP2 just allows you to process them in parallel, but it is not guaranteeing that it will work. So you may see that on some kind of non-HTTP2 optimized applications, that they work like their waterfall. It looks pretty similar to what you see for HTTP1. For example, um, this waterfall here. Yeah, so at least at the beginning, it looks pretty the same. So we have 1, 2, 3, 4, 5, 6. And then after first one is processed, then next one is sent. So generally, you see the regular HTTP1 workflow with kind of 6 threads, yeah. But we are using HTTP2. So because of like HTTP2 allows you to have this prioritization, right? So you can specify the priority for separate streams. So if some resource is dependent on other resource, like in this example, so if some image is needed by CSS file, we cannot load this image before CSS file is loaded and processed, because browser should know which request should be sent, right? Yeah, it could be kind of handled using this preload, when you send, let's say, one request to HTML page and all stuff is responded back to you. But in regular case, it will not work like this. So when you are moving to HTTP2, you also need to expect that there is possible work on the client side for kind of optimization, like to optimize your application to utilize all the features that HTTP2 provides and allows you to have. And let me show you here. So in DevTools, by default, you do not see the protocol or the connection ID by default configuration. So I would recommend you, so if you want to check is HTTP2 is working on your application at all, or is it working fine, just to validate it, you can add the protocol column and also the connection column. And as you see here in protocol, we have H2, it's HTTP2, and the connection ID, it is the same. So it's a single connection. For HTTP1, you would have 6 different connections here. So kind of here we're using single connection, but the flow, it's more like HTTP1 related. Not even related, HTTP1 based. Yeah, that's how your application is designed to work in this specific case. And let's try to see like how different. So probably you do not see it. Let me just show it like this. So you see all the charts. This video should probably hide it. Yeah. So let's check different cases. Kind of to verify. I want just to show you how you can verify that everything works fine, because it's specifically what we will need to do with JMeter thing to validate that it is working properly. So in this case, we have 4 different cases. So case A, it is HTTP1 requests using single connection. You see how it looks like. It's just 4 separate requests. They are executed one by one. So we have single connection, HTTP connection. It allows you to send only one request and at a time. So we send a request, got the response, and only then we are able to send next request. And that's exactly what do we see here. Second case, it's HTTP1, like more regular case for browsers. When you're operating HTTP1, you're allowed to open up to 6 parallel connections, HTTP1 connections. So in this case, all requests, we have 5 requests, they are started at the same time, so they are processed in parallel. So this case B, C, and D, they looks pretty similar, right? So comparing to A. So here everything is sequential. In case B, everything in parallel, C also in parallel, and D also in parallel. But what we need to consider here that C and D, it's HTTP2. So HTTP2 and multiple connections, it's case C. So it's pretty similar to what we have in case B, but just we changed the protocol. So instead of kind of using normal single HTTP2 connection, we are using 6 of them. Looks similar, but you are not like getting those benefits of HTTP2 optimization, like reduce of this like round trips on the connection itself, like reduced amount of connections, resources for utilization for setting up this like this SSL negotiation and so on. So the one we are interested actually, what is the normal one, is the case D, when we have single connection and requests are multiplexed. So they are sent in parallel using single connection. And from kind of user perspective, they look pretty similar. So we need to know more about how we can identify where we're using a single connection or different connections, because it looks pretty similar. And that's how it looks in log. So case A, let's try to analyze the details. So what we are interested in is actually the connection ID. So in case A, when we are using single connection, it's one value here for all requests. In case B, where different connections. In case B, yeah, it should be different. Wait a second. So we have different. Stop. It's not the right. I just messed up with columns, because in my log the connection looks like this. Yeah, that's right. So connection is here. We're using the same connection. It's the case A. In case B, when we are allowed to open up to 6 requests, it is like 26, 25 different connections. And case C, again with multiple connections, we again have different. And case D, the right one, is the single connection. And we can see that in case 1, we used single connection, and we executed 5 different requests through this connection. In case B, we utilized 5 different connections, and each of them got only 1 request. In case C, the same, different connections and only 1 request per connection. And in case D, like the right one, HTTP with 1 TCP connection and multiplexing, we use single connection, and all the requests, they were processed using this single connection. So that's really important information that we need to kind of remember, because that's what we gonna do to validate that everything works fine on our side, on plugin side. So how we can validate this? So I just showed you some kind of logs, right? So first of all, as I said like a few minutes ago, you can utilize from DevTools. It is showing you pretty well, like this high-level stuff. Protocol, just add the protocol and add the connection. So if you are interested just to see what application, what site is using which version, you can also install this plugin. And it will be identifying the protocol. So it will just show you, like, is it HTTP1, HTTP2, or HTTP3 used on this site. So I was not using it too much. I installed it just to try, but for me it was not a quite a big value from it. But DevTools, it really helps to see the protocol and the connection IDs. And also what you can do, it's even more flexible, and will be heavily used in our today's session. It is proxy debugging tools. So in my case, I used the Charles proxy. I also tried to use Fiddler, but like it was not able to to provide me like the necessary metrics I was interested in. So, and I was actually interested in, first of all, its protocol, that is HTTP2, and Fiddler was not provided, was providing it, but I was not able to find these details like the stream ID, the client and server settings frame, and connection number. So in Charles, you're able to get any request, go to connection block, just expand it, and you will see client connection, server connection, stream ID, and client and server settings. So client and server settings frame, it contains extra information regarding how client and server could interact one with each other. And one of interesting parameters here is max concurrent streams. You may see it. Yeah, probably it is not available on the screenshot itself, but that's what you see in settings frame. So usually browsers, in my case, it was Chrome. So it just allows you to do this thing, and by default, it has settings max concurrent streams 1000. So it means, so actually when your connection is established, so amount of streams you can specify, like amount of streams that might be created by client, they are not kind of infinite. So they are limited by this max concurrent streams parameter. And like, by default, it's unlimited. But in browser, for example, it is limited by 1000. So it means the browser, it is allowed, or it wants, to create up to 1000 parallel requests sent through this connection. And like, this RFC, like 7540, it is recommending you to send it not less than 100. And what do you mean, like recommend to set this value? How? It is set in browser. How can you control it? Actually, you are not controlling it in browser, but you can control it on server side. And generally, client. So if we have two different values, let's say client max concurrent streams is 1000, but server side it is 200. Then client, it should obey this server side value. So client should not send more than 200, because that's kind of limitation of server. For example, in this case, so it's just comparison of Chrome versus server, and Chrome JMeter versus server. In this case, server allowed us to send maximum 128 parallel streams. So browser will do it, and it will send not more than 128. It was kind of in introduction, right, for you to understand how it looks like. And now the topic why we came here. So it's HTTP performance testing using JMeter. So here, like I will have several, maybe 5 or 6 different slides. It's just really high level summary of what we are going to talk about, like for next hour probably. But I would not stop here right now with this like too long don't read stuff. It will just, I'll just keep it for you, like if you want to go through this presentation later. Let me again make it smaller so you can see it. Yeah, so just spend a few seconds here. That's what you need to know. Again, do this stuff. And some extra configuration. So just a high level overview. So generally, long story short, all available plugin versions that are available right now in Plugin Manager, so it's the legacy one and the 2.02, you cannot use them actually to test HTTP2 normally, because this 2.02 version, it is not even, so legacy version, it has it is not flexible. It is pretty limiting you in which test you can create, how you can validate it, and also how you gather metrics. Because of why? Because we'll talk about it later. And this like new version, like 2.202, it is not even supporting the multiplexing itself, and it was kind of the biggest weird thing I saw when I was validating it, because generally HTTP2 should be tested to validate multiplexing. How, like, what is the advantage of sending parallel using one TCP connection? Because one TCP connection should reduce the server utilization. It should just work faster, and also like we should be able to send a lot of requests in parallel. But the last version, it is not supporting that at all. Yes, it is sending requests using HTTP2, but all requests, they are sent in parallel. So it was pretty weird thing. That's why actually I am doing this event, because there are a lot of pitfalls and kind of hidden things that you probably may not notice. Because generally this upgraded version to 0.2, it was available in Plugin Manager for maybe for a year. So some time ago it was a legacy version, maybe 4 or 5 years ago. It has its own disadvantages and inflexibility and so on. So it had a lot of problems. So the plugin devs, they decided to kind of refactor it, create a new version, but this new version was not actually testing the features we need to test in HTTP2. And I am just wondering how many people used it without, because I was not able to find any defects created for this. So probably a lot of people got invalid results because, yeah, we tested HTTP2, it works fine. Or we tested HTTP2 and there is no significant difference with HTTP1. Because probably the problem was in the testing approach itself. So yeah, you can just go through it, and we will have the same slides at the end at the end of this presentation, so it will be more like meaningful. And now let's start with details. So what I want to show you again, in this HTTP, I wasted a lot of time on this HTTP2 stuff when I was testing it for different validations, some testing, kind of to make it working. And it is just a spoiler. So the plugin, it is not kind of, it doesn't have everything fixed. So I worked with plugin dev, David. It's really cool guy. He helped a lot to kind of fix at least some issues, some critical issues, to make it at least usable somehow. But it still has several open issues or kind of limitations, challenges that is not allowing you, like to just have the seamless experience without any butt hurt. So I want to provide as many details and updates and kind of give you understanding of what was going on. So what was the initial state of this plugin, which is available in Plugin Manager right now that like you can install, and like what was the changes done. So just considering that it is still not finished yet, so it is not kind of working 100% perfect. Maybe you will face similar issues, and instead of wasting tons of time on researching, profiling, debugging, and all this stuff, you can just like you will be just like aware of what's going on and how you can at least kind of work around it. So it will have a lot of stuff, but let's start from the initial state. You're able to install two versions. It's HTTP2 legacy plugin and HTTP2 plugin. Yeah, legacy plugin, it means that developers, they are not expecting you to use it, and they don't want you to use it, but still you're able to install it. And as I said, both of versions, they are pretty like kind of hard to use in different aspects. But we'll talk about it right now in details. So to install, let's start with the latest one, 2.02. First of all, you need to install Java 11. So it is required because this HTTP2 client, it uses the Jetty server client for HTTP2 client implementation. And this Jetty requires you to install Java 11. So otherwise you will get this error, and also you will get something like that the client has been compiled with a more recent version of Java runtime. So you need to install it. And also, just a few, by the way, a few days ago, JMeter 5.6 was released, and they changed UI slightly for HTTP request, for HTTP sampler. And at least this HTTP2 plugin is failing to start. So there is an issue on their GitHub, so they will eventually fix it. But still, it will not work in 5.6, and probably other plugins might not also be working there. So just use JMeter 5.5, at least for now. Documentation is available on their Git. It is really high level and like kind of it lacks of detail, and that's kind of another reason I am doing this event, to share all the pain, all kind of undocumented features that might be used, just to speed up your testing process. So I just installed this 202 plugin. We can add the BZM HTTP2 sampler. So the sampler itself looks pretty like the regular HTTP request, HTTP request you have for HTTP1. And I just created simple, quick validation for this HTML. That's the HTML from the site, from this demo site we used. So when you clicked on HTTP2 on that site, it was actually sending request to this URL, and it works. So we see that, and I was pretty happy. It's cool. It works. It is able to send request. It process it, and even it tells that the protocol was HTTP 2.0. Perfect, right? And also, if you are testing your web server, especially if you're testing the cached resources stuff, you can also see, for example, this X cache miss. So it means that this resource was not available in cache. So we got it from the origin server. But all next requests, they would have cache hit. So we served the cached version. Okay, but like I specifically, like I intentionally even told you all these kind of details about multiplexing, different streams, how it should be processed. So let's validate. And it was like I was also at the same place. So I was reading about how HTTP works, what are the benefits. So when I started using this HTTP plugin, my goal as the performance engineer was to validate that it works as expected. So I did the next thing. By the way, in like many further slides, you would see some messages or errors in log, and this plugin. So to see like, HTTP2 related messages or errors, actual errors, they are logged only in debug mode. So to see them, and also if you will like work with HTTP2 and you will struggle with some problems, you can switch log level to debug and you will see more information why something fails. Because sometimes before dev told me that, I was on info level, and like I run the test, something hangs, I do not get result in listeners, and I do not have any errors in log, in info. But just switch to debug. So to validate that kind of it is HTTP2 and it utilizes the same connection and different streams and sends in parallel, so it is multiplexed, I used the regular proxy configuration on request. So you can go to request defaults, add just the config element HTTP request defaults, and configure it in proxy server block on advanced tab. Specify localhost 888, and like on the same laptop, you should be having your proxy debugging tool. Like in my case, it was Charles Proxy. it by default it starts on 888 port. And in a proxy on Charles, you see the protocol was 2.0. Perfect. And also even in the view results tree, you also have the results, and it's also HTTP2. Perfect. But if you add several requests in a row, you will see that they are processed sequentially. So actually, they are processed as a regular HTTP request in JMeter. So JMeter is a synchronous tool, right? So all the elements, they are executed one by one. And it works the same with HTTP sampler. So it was kind of, at the same time, it was expected and it was not expected. So it was expected because that's how JMeter usually works. That's fine. But it was not expected because I expect HTTP2, at least from what I read and what I saw from different articles and like videos, it should be sending request in parallel. So I should be wondering, how can I send request in parallel, right? Because that's the main thing I want to check. So I want to test what is the performance benefit of using HTTP2 so I can send 150 requests in parallel comparing to only 6 parallel requests for HTTP1. Let's check some details. So at least we see that this connection is reused. So if you go to connection and check the server connection, it is the same value actually here. And the stream ID is also changing. So stream ID was 1, and now stream ID is it's 3, but not 1. So it's another stream ID, and we know from the previous slides, we know that different streams, they are used kind of to send, like it's the mechanism that allows you to send requests in parallel. But in this case, yes, it was 2 separate streams, but requests were sent sequentially, unfortunately. So where is the promised like multiplexing? So I want to execute request in parallel. So okay, I thought, yeah, so those, in that application, we are opening HTML page, and then all the static resources, they are loaded in parallel. So I thought maybe let's just enable retrieve all embedded resources, and it should be working properly. At least we can parallel it in this way. Okay, go to request defaults as usual, advanced, retrieve all embedded resources, click retrieve all embedded resources, and parallel downloads. So let's see how it goes. Yes, we started JMeter as usual. As a usual HTTP request, JMeter parse your HTML body, find all the same as browser does. Find all the required resources and send requests for them. But it doesn't look like what we saw in browser in like on demo, how HTTP2 works, right? So right now it looks more like HTTP1 way of interaction with server, right? So protocol is HTTP2, right? But connections are different. So I expected to have same server connection, but in this case they are two different. It's just the two like 99th request and 98th request, so they are kind of close one to each other. But connections are different, but it's HTTP2, so like it was pretty confusing for me. Why it works in this way? So when we try to do the same in browser it uses the same connection. You can compare. Server connection is the same. So in JMeter, it works differently from what we have in browser, and that's kind of the first problems. The first problems we are starting to face. In browser, again comparing, yeah. In browser, everything is started at the same moment. Connection ID is the same. Yeah. So, and when we check when you just connect run JMeter in debug mode, connected to the code itself, I see that when we run test with retrieve all embedded resources and parallel downloads, JMeter is actually creating a lot of extra threads. So that is the main thread, and there are a lot of HTTP clients, not even 6. So we specified here 6, but generally it created tons of them. So if you go and disable parallel downloads, so it creates only one extra thread, but still it is creating extra threads. And even if we disable this parallel processing, we have one TCP connection, right? But the processing itself, it is even worse. So it is sequential. So for now, I see that the logic, how it works, it's pretty similar. Like it just reminds me the HTTP1 behavior. So it looks like this HTTP2 plugin, HTTP2 sample request. It is sends request using HTTP2 protocol, but it is not doing this like single connection multiplexing with streams. So all these like benefits that we need to gain from HTTP2, they are not utilized. And that's kind of weird because what I need to test then? That I just switch from HTTP1 to HTTP2, but I work in the same manner as HTTP1 does. No, it's kind of it's crap, right? Because just switching protocol, it is not giving you too much benefits. You need to utilize single connection and multiplex requests using multiple streams, and that's kind of weird. So how it should look like in browser and how it looks in JMeter with parallel downloads and without parallel downloads for embedded resources. Kind of disappointing. I at that moment I didn't know that like how long this way would be. So I tried to play with available parameters. So there are quite of maybe how many 10, 15 different parameters available in documentation. So we can, I see that, okay, we have minimum threads, maximum threads, like connections per destination. So, and that's actually it, right? So, or max request queued, but max request queued is pretty big value. So I tried to play with these min threads and max threads, but it didn't help actually a lot. It was not changing it significantly. So there are here's two different cases. This upper one is the JMeter, lower one is browser. So in browser, everything is executed in parallel, but in JMeter, even with max threads equals 100, it is kind of sequential. And if you connect the profiler to JMeter, you will see that a lot of these HTTP clients, they are created, but they are doing nothing. So this yellow state, it's waiting. So they are just created and just waiting. And only like few of these clients, they are actually interacting with network. So they are sending and receiving data through it. So it's kind of the huge overhead. And that's kind of that these properties mentioned here, they are not actually helping you. So that they probably just they were left from that previous legacy version. So actually, they are not helping you for this new plugin, unfortunately. So I also played with different configurations. So it's what if we set minimum threads to 1 and maximum thread to 1? Yes. Now it creates less clients, like more of them, like all of them doing something, but still they are not parallel. They are executed sequential. yeah, so we are not generating extra connections, like all these extra threads, but it is not working as expected. So at this moment, like I tried much more different cases, but they were not helping me. So I tried to use this legacy version, just because in documentation. So first thing I noticed that the legacy version, it had much better, like it had detailed documentation, because the previous version, it was kind of developed for like it was developed and maintained for like 3 or 4 years. So they had a lot of time to like add some corner cases, some problems there, and it was mm, more like well described. And important thing I saw there, it's the limitation block, a huge paragraph with the limitations. And that's actually why they moved from this legacy version 1.6.2 to like second 2.0.2 version, like new major kind of release, because it was redesigned from scratch. For legacy plugin, it is processed asynchronously. So it is async requests sent. That's actually what you need for HTTP2. But the problem is that the JMeter nature itself, it is synchronous. So JMeter expects like requests to be executed sequentially, one by one, and that's how the JMeter engine actually works. So it expects to execute preprocessor before sampler, then it executes sampler, then it executes post-processor, then some assertions, listeners, and so on. And that in this legacy implementation, it is the biggest problem here, because they did it kind of totally async way. Yes, it was able to send requests in parallel, kind of use single connection and multiplex them, but it was kind of the crazy problem in terms of creating and managing your scripts, because all your post processors, assertions, listeners, they are just not working, because JMeter, it doesn't know about all these async requests. So even to see any results, even some small results, you need to use the separate elements. So you need to use, let's say, you want to use request defaults. You need to use separate HTTP specific request defaults. Request it specific HTTP2 request. View result 3 specific view result 3 HTTP2. Because in all other listeners, you would not get any results, and that's kind of a really big problem, because you are not able to get summary report, aggregate report, any like charts. Even you could not use a backend listener to send metrics to your database. So it's kind of crazy. And also big problem is that it is not allowing you to use proxy. So this HTTP2 request, like this legacy request, it is deprecated right now. It is marked right now as deprecated. They are not. It is not using. So you see the UI itself. So it's pretty custom HTTP to request. So it is quite different from what we see in this 2.0.2 version. Because in 2.0.2 version, it looks like the regular HTTP request. All the fields, everything is the same. So this one was a pretty custom one, and it was not using proxy. So actually, you cannot even validate, like, does it multiplex or send through one connection or not. So it's pretty kind of limiting you in development and also in test execution. And also I checked the issues on Git, and there are a lot of performance issues related to that legacy version. That's why they decided to like redesign it from scratch to eliminate at least all these limitations we had. But still, for me, it was not at that moment, it was not a blocker. So I wanted just to make that request parallel. I want to multiplex them. And you can actually do it. So I tried to load the same request. So it had 170 embedded resources, and it failed with timeout. And that's when I started feeling again the new piece, like a new portion of pain. But Stack Overflow suggested to increase the heap size at least to 5 gigs, and it kind of partially helps. But come on, single request with 170 resources use 5 gigs of RAM. That's crazy. That's where this performance limitation comes, right? Because even for single user, 5 gigs of RAM, it's not bad. But even I also set the timeout. It also was suggested on Stack Overflow, but even here, it was not working 100% successful. Yeah, I saw some successfully executed requests, but again, another part was failed. And the problem is actually only first 128 requests were processed successfully, because our server, it has this, let me find it. In that second frame, remember I shown you, okay, it was so long ago. Come on. So our server is allowing to process only 128 parallel requests, but JMeter was trying to send 170, and that's where the client was like struggling with. So I tried to send 170, and how many? 42. They were not accepted by server. Okay, I just failed. That's it. That's how it worked. So actually, in this specific application, it was not working. Like, it was not able to process all the requests. But if in your case you're going to send like less requests simultaneously, like at least try to send, then it should work fine. But still, you still see that it is not working. Kind of, you understand why the new version 2, like 202 of plugin, was developed. So yeah, let's at least try to kind of figure out what is it. Is it sending? Is it multiplexing requests? So as it is not using proxy, like the one way I just decided to validate it, I just added the time function to request name. So actually JMeter will add the timestamp of when request was sent. And as you see, so it's like 350, 350, 352, 353. So they were started like with maybe 1 or 2 millisecond difference. So actually they were started at the same time, and as well as these ones. So you can even group them. So it is multiplexing. So I am not sure are we using single connection or not, but probably yes, we're using single connection. And this new plugin 202, it is sending requests sequential, so the same configuration. But we sent so first one. Okay, let's even start from the end. Last one is 313, then 255. It's kind of difference. How many? Like 60 millisecond difference. That's how long one request takes. So usually we have 60-70%, 60-70 millisecond difference between all these requests. So what does it mean? That yes. Oh, you was not able to see this one. Okay, it's like 980 and 937. So it's just a difference for single request. And what does it mean? That yes, the new version, it's much better from the kind of JMeter standpoint. So we are able to use post processors, listeners, all the listeners. We can use the regular config elements. So the same as we do usually when developing just HTTP 1 tests. But it is not able to utilize the multiplexing at all. That's kind of blocker, and it is blocking us from doing the actual testing. So, like just some assumptions after using these two versions. One legacy. So legacy, it is able to multiplex requests. It is able to make requests sequential if you need that. So you can do it. You can make it sequential by clicking a special checkbox on the request itself. Here you can make it synchronized request. So if it is not checked, it will be parallel. But that's actually all the advantages of this legacy plugin, because other than that, it is not allowing you to use post processor and assertions and even listeners in any like normal way. Data will just not be reported there. Why? Because actually, at the moment when listener is executed, those async requests, they are still in progress. So JMeter is not waiting for them to be processed, at least in that implementation. And also there are a lot of different performance limitations that it is not handling properly a lot of stuff, or just utilized a lot of resources, like to load 130 requests, 130 requests, you need 5 gigs of RAM. That's crazy. And for HTTP2, like this initial version that is available in Plugin Manager, so first of all, like it kind of inherits all the regular, like all the methods that are available in regular HTTP1 request. So you're able to configure proxy, use all the regular elements, config elements, listeners, post processors, preprocessors, all this stuff. But that's the one advantage here, and a lot of disadvantages. So it is using different connections for embedded resources, but in browser it's single. Then requests are always executed sequentially, so we are not able to like utilize this multiplexing and send them in parallel. So when we send, oh, it is just duplicate one. Let me just remove it. So if we have all embedded resources enabled and click enable parallel downloads, then it creates extra connections that should not be done. Lack of documentation. JMeter client settings, this client setting frame, is different from what from what browser specifies, for example. And we're not able, so all the requests, they should be created manually. So even if you have the so how do you usually work with HTTP1 and you have the web application? You start the recorder and you record all the requests, like a lot of requests from your application, including headers, including parameters, and so on. But in HTTP2 case, you need to implement them manually. So that's the initial state, what we got, and that's what we tried to fix and improve, at least to make it usable somehow for our testing purposes. So I checked the repository, find a few guys who committed to repo, and just connected them on LinkedIn, because at that moment I was just not sure, is it really not working, or maybe like because of kind of really high level documentation, maybe I'm missing something. Maybe you need to use some extra properties in JMeter properties, or do anything to make it working. But no, it was actually not working as expected. I don't know how it lasts for 1 year from this like 2.0 release, 2.0 plugin, JMeter plugin release. So somebody was using it. I am pretty sure that somebody was using it, but actually they were not able to test it properly. I'm 100% sure that they got kind of invalid results, and that's pretty sad that people they are not verifying what they are doing, and that's regularly like when I am on trainings, when I'm talking about like different bottlenecks, right, where the bottleneck might be. And one of possible bottleneck type is kind of your testing approach. How do you script? Like how do you test? And that's kind of really great example how you can easily get invalid results just without validating what you are doing. So how it will look like? So we have a bunch of initial issues. So actually, we have like everything I mentioned just a few slides before, uh, and we'll have like on a lot of slides. We'll have it in next way. So it will have the version. So right now in Git, there are 3 extra like alpha versions. It's 2.03, alpha 1, alpha 2, alpha 3. So alpha 1, alpha 2, alpha 3, they are published on Git, but there were so most of our communication with David. It's plugin developer. Again, big thanks for him for all like his efforts. He was like making to make it better. But a lot of kind of changes they were intermediate changes, so they are not published to Git. So we were trying kind of I highlight some problems. He's trying to fix them. We retest, revalidate, maybe fix something more, and only like after like several versions, like these intermediate versions, it was released to Git. But it is not. It's available on Git, but it is still not available in Plugin Manager. So even right now, after the Alpha 3 is available on Git, and I would say that even there is Alpha 4 with some performance improvement, but it is not yet published on Git. You are able to build the jar file, the plugin by yourself, but you cannot download it from Plugin Manager yet, just because it is not finished. So if you see just alpha 0.1, then it means that intermediate version, and you will not see this kind of release or tag in Git. But all the changes, they will be included. So actually, the alpha 1 it included 3 intermediate these versions. So and we will see the structure of slide will be like this. So it will be like some version changes or notes. So actually here I want to kind of provide some details, what was changed, why something was changed, what are the common problems that we might face, because you might also face the same problems actually. So you need to like you can get at least some context of what was done, because I am not sure when all this stuff will be like finished and documented, because there are a lot. So I have like maybe how many 120 slides for this presentation. Probably half of them is just all the changes we made. Yeah, so it's 50 slides with different changes. That's why there are a lot of different changes. Maybe we will not go too deep into them, but I just want to kind of to save it at least somewhere, because most of communication we made, because there were a lot of discussions how to make it better, or like why it is not working. We just communicated in private messages, so it is not kind of saved anywhere and available for everybody. So it is changes. So it's usually changes and notes from the dev. So if you see here that something like I changed the plugin, so it's not me. It was David, who is the developer of the plugin. When you see something like version validation, it's my assumptions. So I tested it. I tried some cases, and it is working fine, or I have some more concerns or blockers or challenges here. So just keep it in mind. So in the initial version, so we were able to process. So we kind of tried to fix the problems one by one. So first big problem was related to embedded resources. That embedded resources, they are not processed in parallel. So they are using single connection but executed sequentially. Yeah, that's the major change. And after this change, actually nothing was changed. Nothing much was changed. We still created a lot of different threads. So he referred to max threads and max connection per destination. But remember, I already tried this before, like refer to these max threads, play around with them, and it was not actually helping much. And in this case, it also haven't helped much. Yes, there are like something was changed because initially in initial version we had only like a few clients, few threads doing something, but in this case, yes, we have 10 different threads and all of them they are doing something, but you see there are no point where everything is executed in parallel. No, they are just executed sequentially one by one. And in Charles, again, everything is sequential. So when you are testing this HTTP2 stuff, the profiler, in my case it was JProfiler, or you can use Visual VM for free, and Charles proxy or some other proxy, they are really your best friends to identify how it works under the hood. Because without this information, it would be much harder to kind of validate what is going wrong, because we can just guess what's wrong with it. So second version, so there was something blocking. So he made some changes, but JMeter was not actually using them. And our after the fix, it started working better. But to enable this parallel processing, you need to, so after right now, you need to enable parallel downloads. But important that this value 6 that we have in like parallel downloads, and then 6, that usually for HTTP1 we specify like the 6 threads or connections which are usually allowed by HTTP1 to be created. So this value is ignored. So HTTP2 will process it just in parallel. And do I have the screenshot? No, unfortunately, but it started working in parallel. I don't have a screenshot here, just trust me. But still, this parallel execution, it works fine, but it works only for embedded resources. So in case when you want to create kind of realistic scenario, you cannot do it. So in this case, the example here, I want kind of emulate realistic my client behavior, browser behavior. Let's say I have HTML page downloads static resources, like all the embedded resources in parallel. Yeah, now plugin can do it in this version. But what if I want to execute, let's say, these two requests, 2, 3, and 4 in parallel? Or I want execute 2 in parallel with 1 and 3 in parallel with 1 and 2. So I want to execute 1, 2, and 3 in parallel. Then I want to execute number 4 sequentially after number 3 is executed. And then I again want to execute number 5 sequentially, and then execute these 3 requests in parallel, kind of emulating some Ajax calls sent in parallel after some JavaScript that is executed. So it's kind of ability to make your script more realistic, because right now all multiplexing is applied only to embedded resources. But except them, we can have a lot of dynamic calls that also should be multiplex. That's the next goal we need to fix. And I had several ideas how we can do it. So first one, we can just specify, let's say we can use some controller to kind of make something parallel, similar to what parallel controller does for HTTP, regular HTTP requests, right? But why can't we use parallel controller here to execute? Let's say I want to execute these 3 requests in parallel, or these 3 requests in parallel. Let's just add them into parallel controller. Unfortunately, it will not work, because first of all, parallel controller is a kind of known problem with it, or limitation. That parallel controller, it creates separate connection and separate thread for each request inside it, for each element inside it, actually. So instead of using single TCP connection, we are going to use many connections, and it will not be the normal HTTP2 behavior. And that's why it is not working. Or we can add, similarly to the legacy plugin, we can add just some flag or checkbox or some property to make requests sequential or parallel. And that's what was the initial kind of ability for us to make them parallel or not, is to use add preprocessor to the request you want to make parallel. You want to make parallel, and use sampler.setSyncRequest false. And where you add this preprocessor, those requests will be executed in parallel. So it's kind of made us able to send something in parallel, but it had one big drawback. Again, it was sent asynchronously, and regular listeners, they were not able to get those results. So in the results, like all sequential requests, sync requests, you would see first one, third one, fourth, and fifth, but second, 6, 7, 8, 9, they would not be displayed in view results 3. But these samplers, at least they are using proxy, so at least we can validate had it helped us or not. And if we check Charles proxy, that's exactly what we needed. So we got all embedded resources loaded in parallel, you see. Then we got 2 requests in parallel, 2 and 3. Well, I wanted 2 and 3. Then 4 and 5 sequentially, 4 and 5 sequentially, and then 4 requests in parallel. Again, this one is sent to. So now, yes, we do not have all the results in listeners. That's kind of drawback. It's a big problem, but still, we can play with the flow itself as we wish. So we are able to send requests in any flow we want to design it. In next version, actually, David designed kind of the new element. It was called HTTP2 async controller. So this controller allowed us to do actually the same thing, but in previous version we used that preprocessor. So right now we don't need to use preprocessor, but we are able to place all the requests we want to execute in parallel in this HTTP2 async controller. So you might ask, what is the difference between parallel controller and HTTP2 async controller. It's the huge difference. First of all, because it used the single connection. So it used the single TCP connection and send requests in parallel, like multiplex them. So that's exactly how we want it to work. Another important thing that this async request, so this async controller, it is handling this async processing and like in terms of JMeter engine. So we are able to get all the metrics in view result 3. So we solve like two problems, parallel execution and gathering all the metrics in view result 3. That's yeah, there was few problems with it. Oh, I don't have a picture. Okay. So what was the problems with this initial version? So it was this async controller initially. It was failing with like it was not waiting until all the embedded resources they are downloaded. For some reason, it was just stopped. And generally, the problem was in this response timeout to 0. So this property, JMeter property, it was not properly handled in the HTTP2 plugin implementation. That's why like just requests were failed. But in new version, it was failed. It was failed. It was fixed. So even without implicitly specifying this property, it was working fine. And we were able to generate the logic in the same manner. So it is like two parallel controllers. Come on, which parallel controllers? It's how it's called, HTTP2 async controllers, where you are able to define what should be executed in parallel. So we want to execute these ones in parallel, then execute two sequential. So we put all sequential requests that we want to have out of HTTP2 async controller. So in this case, we want to execute these 3 requests in parallel, then 4 and 5 one by one, and then after 5th one, execute these 4 again in parallel. And again, few problems I noticed here, again related to these 128 embedded resources. That limitation which comes from server, maximum amount of concurrent streams. We see that requests, they start to initiation connection once again, like from scratch. So we see that it has connection times. And also I observed some weird behavior in response time calculation. So in Charles proxy, you are able to validate, you are able to see what was the kind of response times for each and every request. And if you compare, so I compared some resources in Charles, it's 61 seconds, in JMeter it's 75. Some requests which are sent in parallel with HTML, like some dynamic calls, it was 167 in Charles and 1.3 seconds in JMeter. So 60 milliseconds versus 75 milliseconds. It's like we can just say that it's kind of like extra overhead from the profiler or from the JMeter or whatever. It's a small difference, but 167 millisecond and 1.3 seconds, it's quite a significant difference. And the total duration of all requests, so we have all the requests processed. So in Charles it's 1 second, in JMeter it's 5.4. So something is wrong just with the response time calculations. And also, if you want to check what is the total processing time for this async controller, right? So if you place it like in transaction controller, you will get like all the response time. Let's say you have 10 requests. So the total response time will be calculated just as a summary of all requests. But we are processing them in parallel, most of them. So it should not be done in this way. So it should more look like kind of it should more look like the parallel controller processing time, because parallel controller is calculated it just how long it took to execute parallel controller, not how long it took for all requests to be executed and calculate total some of them. And also number of samples in transaction, they were not correctly calculated. That's kind of new issues we faced with this new async controller, HTTP2 async controller implementation. Okay, new changes. So timings were adjusted. So now timings are like are got from the Jetty itself. Jetty is a client which is generating these requests. So we are getting all the stuff there. So you can read all the details if you want. And there was a few extra, like it was a few extra fixes here. In another version, what we got? So now I faced another issue. So if you disable all retrieve all embedded resources, you have all embedded resources enabled, but parallel download is disabled, so it is unchecked. So it is failing. It is failing. You can see the error in logs with out of memory errors. That's quite interesting. That parallel execution is not throwing any errors, but sequential execution with single thread with no parallel execution, it fails with out of memory exception. It was also failed. So I hope that you will not face these issues. You will not face issues which are already fixed, but who knows? Another thing is okay. So it's actually the fix for this thing. And like right now, this total response time for a sync controller, it is not calculated properly. So it's the big value. So kind of the workaround. Okay, workaround will be later. One more thing, a really great thing added. And by the way, so this one, it was so this version, it is available on Git. So all the previous versions, they are kind of intermediate versions. This one is available if you go to their Git and go to tags or kind of releases, you will see the alpha. So it will contain all the fixes I mentioned before. So actually, you can use it at least to test somehow at least it is working with multiplexing, and you can create the script you want. And there is one more version called Alpha 2. It includes, it allows you to use just the regular HTTPS test script recorder to capture HTTP2 requests. And that's kind of the big rock here to speed up the development process if you have scripts development process, if you have web application. So yeah, feel free to use it. On Alpha 1, it will not work. Alpha 2 will work. And also, David was suggesting to use these settings. Honestly, I would say that it was not helping me much in my future issues, but still, at this moment of time, he suggested to use these properties just to make them, let's say, saved somewhere. New challenges, or I would even call it new problems and new pain. Go away frame. So go away is the frame when server starts to when servers start like it wants to close the connection or it wants to like reconnect once again, like refresh the connection. It sends you go away frame, and that's right now, even right now, with all the fixes, within Alpha 4 version, in the latest one, it is still like the big problem, honestly, because for some reason, Jetty client is not like properly handling all these cases, unfortunately. So let's talk let's check it step by step. So what I faced, I tried to create, so all the previous cases, they were like on this demo application, and it worked fine. So I was able to run to create some test with some logic, right, to execute it. It was successful. But when I tried to use it with my with our server that we wanted to check, and our goal actually, we needed to check even not dynamic calls. So our activity was related to migrating from HTTP1 to HTTP2 for the web, like for the web server. So initially, all our static content, it was stored on application server. So application server was getting more more load. It was doing like kind of unnecessary work. So the engineering team, they decided to move all the static resources to Nginx. It's a web server, and also switch from HTTP1 to HTTP2 to speed up the loading process. We can multiplex request, and it will work faster. So like the main testing goal was actually just to test, do we have any benefits or maybe even degradations by switching from HTTP1 to HTTP2, and also from switching to application server resources storage to Nginx. And what I faced, and generally scenario looked like, so we wanted to open some page, and each page usually has like 170 requests, 200 requests, around 120 requests, so a lot of static resources required for this page. And what I faced is that some requests, so you start even single iteration, a part of request is executed, another part is failed. Especially it was reproducible with pages where we need to load, for example, 250 requests in parallel. So first part is executed, all others are failed. And I noticed that first 200 requests is executed properly, all others are failed. But when you execute it sequentially, even not using a sync controller, so even if you just send it one by one, it will still fail, but only one request will fail. And that's kind of what? Why? So it turned out that on like if looking closer to details in Charles specifically, we see that the exact like this 199 request is fine. This 200 request is failed, and or actually it's 201st request is failed, and so it is failed on JMeter side. In Charles, it processed fine, but what I noticed there is that it has session resumed yes, and also the ID of connection is also changing. So that's where the problem is. On Nginx, you'll have, depending on the Nginx version or like on other web servers, you should have the same parameters. It's called HTTP2 max request or keep alive request, depending on the version. So it means how many HTTP2 requests could be processed over single connection before Nginx will reset this connection. like refresh or create new connection. And that's what I mentioned. That's the moment where server sends you go away frame. So with browser, it works in the same manner. So browser execute 200 requests, then it receives go away, and it gets the new connection from server. So some requests they are in browser they are also failed, but the problem is that like why in browser is not the problem, because browser immediately retries them using this new connection, and everything works like a charm. But JMeter, specifically this Jetty client and this HTTP2 plugin implementation, it is not retrying at all. By the way, I also tried, so when I was kind of stuck with all the stuff when it was not even working, I also tried to use the K6 for generating requests. So actually in K6, it is like K6, it is hiding these errors. So it is working, like it works, but it also fails. So it is able to process first 200 requests, then these 50 extra requests, they failed. But K6, it retries to send it once again, and like it works fine. But actually, you're kind of not getting the right result. So it is not reporting you all these failed requests. And it's quite kind of interesting information. So I am pretty happy that JMeter is not doing this. And it's showing that some requests are failing, because we identified that in our case, this keep alive request was really low. It was 200. But even default value should be 1000. And who changed it and why? We don't know, actually. So in old Nginx versions, default was 100, but in new ones, it's 1000. So we expect to have at least 1000 in our case. So like we were able to identify this problem at least. But if it would be hidden, probably we would even not pay any attention to this. So that's the first problem, right? When we are able to, when a lot of requests are failed, when the go away frame is received. And there are two different, why in some cases we have a lot of requests failed and in other cases only one. Because actually when you have requests in HTTP2 async controller, let's say you have executed 200, so it should be, yeah, it should be in some slide, but I'll just tell you here. So when you have HTTP2 async controller and you put inside it 250 requests, it tries to send like all of them. But only first 200 is able to be processed, because the remaining 50, when they are processed, server is getting actually coming to this keep alive request. So 200 are processed. It resets the connection, creates a new one, and then all these 50 extra requests, they are just failed. In case when you send requests sequentially, only one fails. Why? Because actually only for this request connection was reset. All further requests, they are kind of not affected. They will just use the new connection. So that's the problem, and actually it still exists. So if, like in my case, if I wanted to work around it somehow, what I would do, so I can, let's say I want to send these 250 requests. So I can do it in this way. I can add one async controller, add 200 requests there, then add one request here, kind of to fail it. Yeah, it will fail, unfortunately, at this state, but still, we have 200 requests executed, one request which failed, and then one more async controller with 50 requests. So generally, we'll have 250. Yes, they will not be processed in parallel, all of them, but still you will not have 50 requests failed. So that's the kind of first problem. Yeah, and changes. So David tried to make the client to use this reconnection. So when go away is received, and actually server tells you to kind of use new connection body, but the client is still not working in this way, so it is not reusing them. And as I said, client is not retry. If something was failed, it is not retrying it, and it is also not yet implemented, unfortunately. So after this reconnection, kind of allowing to support reconnection, actually it was not able to provide any significant improvements, unfortunately. So it was still failing. And also one more weird thing, that after so initially, before these fixes, it was throwing you the stack trace, what was failed, like the connection reset, something like that. Right now, it just gives response with response code 0 and response message 0. And also after failed requests, JMeter starts to send requests using HTTP1. So I have HTTP2 sampler, but something fails on this negotiation state phase, and we start getting HTTP1 requests. That was really weird because it was also not expected. That's why to track these things, what is the actual protocol we are using. Because when you're running your test in non-GUI mode somewhere, you are not able to see view results tree. So I added, I should have the picture somewhere, but actually I've added the HTTP version, protocol version, added again to the name of sample. So all the samples which are reported, they have let's say we have slash login png. So instead slash login png, I'll have HTTP2 login png or HTTP1 login png, depending on the protocol we use. How I did it? Actually, I just got after request is processed in post processor, I am getting protocol from response headers, and using GSR 223 post processor, I am adding this data to sample label. That's how I will have this example somewhere on future slides. But still, so it was somehow working. Yeah, I understand that the problem is that client is not handling this go away, server connection reset properly. But still, we can work around it, right? Just kind of calculate how many requests should we send to fail only one request, not a lot of them. So kind of I just need to create my scenario in this way to have every 200 first or 200 requests failing, and it should be not in async controller. Yeah, it's kind of again extra overhead for your head to think about all this stuff, but still. So I just needed to run some tests. Come on. So I at least try to work around it somehow. And scenario, as I said, it's the multiple transaction controller. So it's usually different user actions with async controllers, and each had 150, 200, or even more, 250 samples in each. But in my case, it was 150, 200, just to be able to control this execution flow. So I have, let's say, 150 and 50. It's 200. Then next one should be sequential, should be not parallel, just to fail this single one. But what I faced, so I created a test. It was working fine on single user on during local execution, but when you run tests somewhere, like trying to generate load, you face really high memory consumption. So in our case, we used the JMeter for this testing because our like internal. So we actually use JMeter and our internal kind of runner, but at that moment, internal runner was there was some issue with it, so we switched to JMeter. And let's see how it looks. So that's in this test we probably had 4 or 5 or only 4 or 5 threads. So this comment here is not related to this specific test. So it's what I faced initially. 4 or 5 threads. Yes, we see that connections. We have only 5, sometimes 4, but yes, it's proper. So we expect this to have only single connection per thread. That's great. But we also see that oh, stop, it's not, it was not 5 threads. It says it was 2, but maybe maybe I missed this thing. So actually low, or maybe it should be, maybe it should be 4 for 2 threads. Why? Because actually the embedded resources, they are still loading in a separate thread. That's how the JMeter engine works. Yeah, probably yes. So it's 2 threads, but one thread is executing like the main requests in your thread, and second thread is executing separate connection, is executing the parallel downloads of embedded resources. Or yeah, so should be working like this. But still, its connection looks fine. We don't have many of them, but like low amount of threads is using 95% of 8 gigs RAM of load generator. It's kind of crazy. It's a lot. And so I was able like kind of work around it quickly by just adding like 30 or 1 minute delay between transaction controllers. So we kind of reduce load at some moment. But still, like we were able to generate only like 20 threads from one load generator. So it's really low values. It's crazy low values. And that's the problem that should be actually fixed. Why it is spending so much time. So the properties that David suggested to use. So first of all, it turned out that Jetty is using not only heap, and it was interesting that in this case, so I was specifying. So they are using X. I forgot what was the instance, but it was something like some large AWS X large, even AWS instance, maybe M5 X large, probably. So actually, if I'm not mistaken, it used 8 gigs of RAM. But the interesting thing that even if I specify locally or on the agent, I specify only like 4 gigs of RAM, I am getting like out of memory exceptions, and like all my available RAM. So it's not even out of memory exceptions, but all the RAM available on agent is used, but it should be limited by heap, right? So usually when we work with JMeter, we specify XMS, XMX, and it is kind of limits amount of memory which can be used by JMeter. But in case of Jetty, it is also using direct memory. So direct memory, it's a separate memory, like it's separate memory settings, which could be used by your application to like utilize different like store some SSL connection stuff, like all like this network communication details and so on. So usually it is not making a big deal. But in this case, all this parallel execution, parallel like performance problems which we have in our plugin, it caused the high direct memory usage. And the interesting thing, why I utilized all the RAM on my machine, because actually by default, Java is allocated the same amount of RAM as you specified in heap. So if I specified 4 gigs for heap size, the direct memory would be allocated extra 4 gigs of RAM. So in general, JMeter may utilize up to 8 gigs of RAM. And that's like what I was not expecting to have. Because let's say I expected only to use maximum 4. And it caused actual like the freeze of instance. So it was not responding. You were not able to SSH there and so on. So yeah, that's kind of the problem when JMeter is using all available memory on instance. So I used this config. So it helped like locally started working better, but on BlazeMeter it was not like it was still failing, unfortunately. So I tried to reduce. So the main problem is actually these go away errors that we are receiving from HTTP2 async controller. Why? Yeah, because when we know that our client is not handling them properly, and that's where, like, if we can like eliminate or at least reduce frequency of these errors, maybe it will help us. So how I try to achieve this? So we know that there are a bunch of parameters available in Git documentation for HTTP2 plugin. So, and one of them, it's HTTP Jetty client idle timeout. So actually how it should work in theory. So this idle timeout, if no requests are executed using this connection for some amount of seconds, it just closes this connection and open new one when like new request should be executed. So it looks pretty logical. So my goal was to add delays between transaction controllers, which is bigger than idle timeout. So let's say I specify idle timeout 20 seconds and sync time, just like flow control action or timer between transaction controllers set to 30 seconds. So how I expect it to work? I have transaction controller, it was executed, all requests are executed, then it waits 20-second idle timeout and Jetty should close this connection. And JMeter waits for 10 seconds more, and only after that it executes next transaction controller. So, and this next transaction controller should use this extra, like the new connection. So it should be kind of workaround for us. Okay, let's keep it in mind. And also, I am trying to send less requests than request timeout value. Oh, it's not, sorry, let me change it. So it's not the request timeout, it's called, it is keep alive requests. So it's keep alive requests. So we should try to send less requests than this keep alive requests on server. So we are not getting these errors like when bunch of like we're trying to send 250 in parallel and only first 200 is executed properly and 50 would fail. So we also want to eliminate and reduce amount of such errors. Okay, but after these changes, I even didn't mention like it didn't notice because I was trying different configurations, playing with settings. So at some moment, I just figured out that in my test, so the same test I was running before, at some moment, my amount of connections, yes, still we are getting, we are using a lot of RAM used. It's not a problem. We're using a lot of CPU sometimes when we are sending requests. By the way, we're using not too much, actually, not too much RAM. So it started growing slower. But the problem is with random amount of connection spikes. And when request spikes, so initially at the beginning of test, it works fine. It works fine. We have like several connections only open. And then at some moment it goes up, like up to 100 connection, then 200 connection, 300 connection, 400. So it's not expected actually. Like in HTTP2, we are not expecting to get so many connections. And at the same time, like what I thought, I remember that in some cases, after some request fails, I got those HTTP1 protocol instead of HTTP2 for some reason. So some protocol negotiation fails, and I am just getting HTTP1. So that's where I got. I added this implementation. So adding protocol from response header to sampler name to know which protocol we're using, and also accept the protocol. I also check in what is the do we hit or we have cache hit or cache miss. It also can be like retrieved from response headers. So it's hit, it looked like this: hit, protocol version, and then timestamp. Also, just to understand when it was sent. And so actually it was HTTP2 all the time, so there was no HTTP1s. And in this case, it was delays. It was even 4 minutes delays between opening different pages, and it was only 5 threads. But still, we were growing up using connections, and how many it was, I don't know, but there was a lot of different connections. So it was spiking, and it was pretty weird. But I just, after some investigation, well, run several more tests, and when these connections, they are growing up, it also starts using more RAM. So it looks like that something fails. It starts to send again a lot of requests in parallel, started using a lot of RAM, and this connection grows up, RAM grows up. It's crazy. So I just spent maybe several days just running, and it's pretty hard to kind of figure out what's going on, because you do not have too many logs, and especially when you're running tests on JMeter, you do not have access to the log generator itself. So it is actually crazy. So in this case, so right now I am running, so I am not expecting. So it looks like something just is going wrong. So at some moment, server is resetting the connection, and we see it clearly, like from local runs. But we should not expect these go away cases at all, because I am doing this idle timeout, which is less than delay between transaction controllers. So as I described like a few minutes ago, so we should eliminate these problems, but we still getting these growing up connections, and it's kind of weird. We can increase keep alive request value. We can set it to 1,000 or 10,000 or 20,000, but probably it will just postpone the problem. So we're still going to get these errors, but maybe less frequently. Like looking forward, actually we increased it, because so these problems with go away, it's still there. So you can increase this value. Like we increased it to 10,000. So we are getting these go away errors less. Also, I noticed the interesting thing that I noticed that even when running locally, so when JMeter fails, in Charles, everything looks fine. So requests were successful. So something is wrong. It's just on this plugin side processing. And also, like some of requests, they are failed with idle timeout 20,000 millisecond elapsed. And it's also weird because why it is counting like idle timeout while some requests are still executing. So it should be start idle timeout after all the requests are executed. So it's kind of open question why it works like this. So it's not logical. And actually, it turned out that the main problem of this extra connection created is those idle timeouts. So actually, I was trying to reduce amount of go-aways. Just kind of, I want my client to close the connection, not the server forced to close it. So we don't have these errors. But with these properties, it was not working in expected way. It just made things worse. That's why, I increased the keep alive request from 10K to 10K to get this disconnect and reconnect actions from server. But I needed to have some mechanism to force client reset connection. And in new version, Alpha 3, so it includes all like previous versions, and also it has a new property called HTTP Jetty client max request per connection. It by default it's 10. So with this connection, the client will close the connection. It will be closed in the safe way before we got the go away from server. So our goal is actually to be faster than server in closing the connection. So it was some challenges in implementing this, but cool that David was able to do this. So at this moment, that's the last version which is available on Git. So all the further fixes and problems we are going to discuss, they are present. Like all the issues, they are present in Alpha 3 that you are able to get from Git. Like Alpha 4, it's not yet published. So if you need, just let me know or let David know in repository. I believe we can share this jar file with you. And probably in future it will be also published there. So this Alpha 3 changes. First of all, it started working better, but when running tests with proxy, like for local validation, it started failing with some concurrent modification exception. So it was fixed. And also, I wanted to figure out how to process. It's even not related to this specific version. It's just a general general question. So I wanted to know. We already talked about it, but here I have the example of it. So I want to understand how long HTTP2 async controller takes to execute. So right now, by design, it just adds all internal response times. So if you have a 10-second response time for each request, and we had 10 requests, then the total processing time will be 10 seconds. But it's not true, because most of the requests, they were executed in parallel. So it should be around 1 second or 1.5 seconds. So how to calculate it? So initial, my idea was to add the parallel controller as a parent of HTTP2 controller, HTTP2 async controller. And if you do generate parent sample, limit max thread and max thread 1, actually you are getting the correct timings. Yes, but you have one big problem. So it will, like, the correct calculation will be added somewhere in future for the plugin itself. But I found, so it worked with parallel controller, it worked fine as a workaround. But when I was analyzing the Charles data, what I have in Charles, I noticed that actually when you're using parallel controller, you are creating the separate thread again, and it's a bad behavior to create extra connections, and it also has like the big performance impact. Why? Because when you kind of create a new connection in async controller, all these requests. So remember, our goal was try to open the connection. Oh, by the way, I was not talking about it yet. Yeah, so it will be later. Yeah, but so one of the kind of optimizations that could be done. Oh, maybe in this case it's not even that case. So when you have, let's say, you have initiated the connection. So your async controller is executed, it's fine, but then you add parallel controller, like in next, as a next step, parallel controller and async controller inside it. So this parallel controller will create the new connection, and this new connection, again, it sends all the requests and initiate the connection for them. So it creates kind of burst of like memory and CPU utilization. So it is not the good way to go with. So as a workaround, you can go to this issue. Actually, I provided the comment there. You can so you have the async controller here, and you can add this set timestamp before GSR sampler. We just specify the current date, current timestamp, and then add GSR sampler after async controller with this code. So it's kind of with little magic here, but still, it will create a separate sample result with this name, and will send it to all the listeners in like in current scope. So as a result, you will got dummy sampler, async parallel controller, that's my name, right? And the proper value, 668 milliseconds. So because actually this time it will include time taken from set timestamp before and after the HTTP2 async controller is processed. So you can use it if you need to calculate like before it will be implemented in the plugin itself. So in this version, in Alpha 4.01, the problem with proxy, it was fixed. The problem with proxy where when you connect proxy, Charles, you're getting like memory leaks and performance degradation. And then, like after tons of different tests and experience, looks like I found the root cause of high RAM usage. And generally, the problem statement looks like this. So when you're using a async controller with a lot of requests, and let's say you just started a test and there is no HTTP2 connection yet, or like if connection is required to be executed, then the plugin, like the Jetty HTTP2 client, it is trying to initiate the connection, but for all the requests sent in parallel. So it's kind of all these requests, they are trying to to fight for resources. So let's say you have 200 requests in a sync controller, and all these 200 requests will be trying to initiate the connection. And that's the main problem, the main cause of generating these high spikes of RAM usage. And I have a bunch of different test cases because like I needed to, I spent a lot of time on experience, but I needed to describe for David how to reproduce it, because it also might be challenging how to reproduce it. And I have like 5 different cases. So first case, it looked like just we have some requests, and then we have a lot of it's just a regular request. It's not even HTTP HTTP2. It's just HTTP1 request. And we have HTTP2 async controller with a lot of requests inside it. In our case, it was 32, but actually the actual number, it depends on the response body, like on the response size. So sometimes it will be less, sometimes it will be more. So it doesn't matter too much. But if what I noticed that, let's say I have 32 plus requests in a async controller, and all of them are failed with direct buffer memory error. Remember that this direct buffer is used for like storing objects related to establishing connection, some session stuff, and so on. So, but I noticed that even if I remove only one request from it, it's a bad picture. It's a bad picture. So on this picture, it should be actually we have we just should reduce. Yeah, it should be case I just messed with a screenshot. So in test case 101, I just removed only one request. It was like 31 or 31 requests, and everything is successful. So it looks like with 32 requests, we are just like reaching a limit of available RAM. But with 30, we are fine. But the question is, why are we using a lot of like so much data, so much memory? So what I tried to do is actually, I noticed that in Charles, I see that, and even in JMeter, if you go in view result 3 through the sample results, you will see that all the requests, they have the connection time. So I assume that all the requests, they are trying to initiate the connection. And that's why they are wasting so much memory. So what I tried to do is just to move one request from this async controller before it. So we have a single request which initiates the connection. So connection is opened, and then HTTP2 async controller is executed. And even to 32 plus, even 80 or like 200 requests will be executed without problems, and the memory consumption will be like much less. So that's kind of the workaround to reduce this memory usage. So right now, again, it is also not fixed in the plugin itself. So you need kind of play around with with moving elements and validating all the stuff you have in Charles proxy to make it working, properly, and reduce this high resource consumption for initiating the connection. So in my case, this one includes 80 plus, around like 80 requests, and it was all of them, they were executed successfully. So I don't have the values for RAM used, but still, it's much better. It's 3 times more than we were able to process before. And also, even if I put 500 requests in this async controller, it also works fine. But here we got back to the previous problem when after 200, so I put 500 requests in single async controller, but our Nginx server, it has this keep alive requests equals to 200. So after 200 requests are successfully processed, it reset the connection, and again we are getting direct buffer memory Why? Because HTTP2 async controller, it still has 300 requests to be processed, right? So it sends 300 requests, and like it tries to send 300 requests for this recreated connection. And again, we are getting back to step 1, when we were failing with 32 plus requests in a sync controller, because a lot of them are trying to initiate the connection at the same moment. So what is the workaround here? So how can we deal with it? So first of all, like if possible, move HTTP2 request before a sync controller. Like in case if you don't have yet the connection, you need to move it. Or if you need to recreate the connection, also just add a separate single request before a sync controller. Or then do not use. So we have, let's say, how many? We have 200 requests, keep alive requests on Nginx limit. So try to send less in your sync controller, or just increase this limit on server. So after we increased it to 10K, it was not it was not resetting this connection too often. So you needed to handle these specific cases like less frequently. And yeah, so there is like the current issues that we have. It's direct memory usage. It's actually not allowing us to get like to generate a lot of load. So it is using a lot of like resources for establishing the connection, because a lot of parallel requests trying to do it. So we can kind of do to stop getting that error with direct memory. We can increase max direct memory size in JMeter bat or JMeter SH in the same place where you specify actually the heap size, but it will not, like, it's not the fix. It will just postpone the problem. Because yeah, I'll increase it to 10 gigs. Okay, I'll just reach this limit later. So it's not kind of the fix of root cause. What David tried to do is actually to, like, what he actually did. It's in version 402. It allowed, first of all, he made the next thing. So by default, Jetty tried to use this direct memory for all this connection negotiation. But he made it to work in this way. So if direct memory allocation fails, then it starts to use heap memory. And if like you don't have space in heap, it will try to garbage collect it and free up some memory. So it at least it will not fail with this out of like buffer, like direct buffer error. And also he added another property called HTTP Jetty client max concurrent async controller. So it allows you to control how many requests could be sent asynchronously in parallel in a sync controller. So it is not. It's more like the fine tuning. So it is not solving the problem itself, because even if I set default is 1000, but even if I set it to 100, let's say, again, so let's say I establish the connection. Let's say I use this new property, max concurrent async in controller. So do I have a screenshot here? No. Let me find this picture again. So I have 500 requests here, and I set max concurrent value in async controller to 100. Let's say, okay. So we have one request before async controller to initiate the connection. Okay, this is fine. Then async controller will execute only 100 requests in parallel. Then it will work fine. Then 100 more, it's 200. But again, still we face the same issue. after we reach 200 requests, in our case, if we have keep alive 200, then actually server reset the connection, and again, sync controller tries to send 100 requests, initiate connection for 100 requests, and again we are getting a lot of memory usage. So my understanding, like my kind of view how it should work, so we need kind of control. If we do not have open connection right now, we need to limit this max concurrent async to 1, but it should be done dynamically in the plugin itself. So if we don't have connection, establish it with only 1 request. If connection is available, then send like any amount you want, or any amount we specified in max concurrent async in controller. So all these problems, they are actually not in plugin itself, because most of these limitations, they comes from Jetty client. And David was able to find some, like they also have a lot of different bugs there. So some of them, they were fixed. He upgraded the version. So this Alpha 4, it is using new version of Jetty and also some other libraries. But still, unfortunately, it was not able to. It started working faster. For example, in 50 thread tests, now it is able to get like 2 times more requests per second than before. But still, it is not it is not able to handle these go away connection reset cases, unfortunately, and it's still not there. Version 404, it's probably it's the last one we got. He also added the delay of 20 milliseconds because he I'm not sure it made it work. So from his tests, he said that it's kind of at least helping in some cases, but I am not sure. I didn't see any kind of improvement after this change. So this 20 millisecond is kind of delay, as he mentioned, to have some time to free up and release the memory which was used for all this SSL negotiation. But unfortunately, it was not working properly. So yeah, that's the last version. So we'll on the next few slides, we are also going to to sum up everything I talked about. What are kind of the workarounds and approaches how you can use it, because there are a lot of limitations and things you need to know. But still, you can, at least at this moment, comparing to the initial version, where you are testing something really random, not HTTP2 at all. So right now, at least from the functional standpoint, it is working fine. Yes, on your project, you may even not face this problem, because if you don't have this keep alive limit on server or any other kind of parameters which force server to reset the connection, then it will work without any problems. But in our specific case, unfortunately for me, our server was resetting connection in a lot of different ways. Before we come to summary, so I also found another kind of another type of problem. Again, with go away, probably with go away, but my suspect is SSL session timeout. So I just noticed that when I run the long tests, kind of endurance test, for example, not for 1 hour, but for several hours, for 4 hours in this case, after 1 hour, part of request they just started failing. After 1 hour more, it again started some failing. Okay, so each hour, more and more requests, they start failing, and they are not kind of restoring. So if it started failing, it will fail till the end of test. So because we are not kind of retrying the failed requests. And my suspect is this. That's the one thing I found on Nginx side. So it's a SSL session timeout. which is exactly 1 hour. So it means that after 1 hour, a connection will be again reset. And that's, again, there are different routes, but the globally problem is really like one big problem, that client is not able to process connection reset. So if you're able to like postpone or disable like any like connection reset in any case, in any way, your performance testing will be much like much easier, because you would not be like you would not need to face all these kind of concerns and problems. So what you will need to do is just to get the latest, like this Alpha 4 build, because it also has some performance optimizations, and you're good to go. So we're getting back to those slides I had at the beginning of this session, of this presentation, with some tips what you can do to make your test valid and like more realistic. So first of all, you have this big set of let me make it smaller. This set of suggestions. So I I moved all like the major ones here, but again, you may also notice some details and really useful information during all these detailed slides, because obviously those slides, they have a lot of context and some general understanding of how it should be done. But here's just a high level. So let's go through these assumptions. So you should not use HTTP2 like 202, which is available in Plugin Manager, because it is not allowing multiplexing. So it is not testing multiplexing. So your HTTP2 testing actually is not testing main feature of HTTP2. Like you are just testing HTTP1 workflow with HTTP2 in headers. That's it, what you're doing. So don't do it. Do not use legacy 162 plugin. Yes, it allows multiplexing, but it is not you will not be able to conduct some normal tests in using it. And also, it is not maintained, so nobody will help you with it. So also don't use it. Get the latest build from Git. So the latest one is Alpha 3 in Git. So you just need to like download it and build the jar file for yourself. Or if you want to get this latest Alpha 4, so I'll write David. Probably he will upload these changes, but still they would not be uploaded to Plugin Manager. So you will still need to build it. Why it should not? Why it will not be uploaded to Plugin Manager? Because actually it is not like, you see, there are a lot of like existing problems there still for release. So if you need this Alpha 4, just let me know. I can share the jar file with you. It's jar file and also some extra Jetty jars. Always, when you are validating your test, try to use Charles proxy or another proxy to actually figure out that your workflow is working fine, that you are using the same TCP connection, you are multiplexing requests and using different streams, that your workflow is fine, so something is sequential, something is in parallel, and so on. If you're using HTML, if you are testing HTML pages, you can enable retrieve all embedded resources and parallel downloads to download them in parallel in single connection. And also number of threads there, it is not like 6. It is not used there, so it will send all of them sequentially in parallel. By default, these HTTP2 requests are executed sequentially. So if you want to make them parallel, you need to use HTTP2 async controller to group them and like multiplex or send them in parallel. Add separate HTTP2 sampler before async controller to initiate connection only with single request. So we reduce like we reduce amount of RAM used for this operation, and also actually not even RAM but CPU too. Reduce possible connection close refresh from servers, because like right now the Jetty or the plugin current version, it is not handling it properly, and generally, so try to like increase all the limits you have as much as possible to eliminate these go away actions from server. If you want to calculate HTTP2 async controller processing time, like the in parallel way, you can use that Groovy script that I shown in this presentation. And do not use parallel controller because it will create extra connections, threads, and extra overhead from RAM and CPU standpoint. And you can also utilize, starting from Alpha 2, you can utilize this record. You can record HTTP2 requests with just, it's not even HTTP2, it's just regular HTTP, the script recorder, which we are usually using while creating tests. For reducing possible connection close refresh from server, you can increase keep alive requests, SSL session timeout on server, or other parameters which are resetting connection. You can lower limit for concurrency in a sync controller, or like limit max request per connection. You can do it. There is a separate slide with different like configs, which might not be documented. So there are two not documented properties: max concurrent async in controller and max request per connection. So you can use them. Also, you can just add delays and increase the ramp up to kind of expand the range when these initial requests, initial connection configuration is established. So you reduce the moment spikes of CPU and RAM usage. And also you can use, actually, again, the separate HTTP2 sampler before a sync controller. Some configurations you can utilize keep alive request, HTTP2 max request, SSL session timeout. So that's what I used, at least in my case, to reduce server side connection reset. We also can use this one to kind of force client to reset connection before server does. And also we can increase, if you need, we can increase or even limit. In my case, I was limiting it, not increasing, because as I said, by default, the direct memory size, it equals to heap. So if you have 4 in heap, then it will be 4 for direct memory, possibly. So I was limited, I was setting, for example, 4 to heap and 500 megabytes for direct memory. And in one of latest versions that David provided, he made the change that instead of, like, if direct memory is not, like, it's full, we cannot allocate anything there, then heap will be used. So that's why you kind of, by reducing this max direct memory size, you are limiting like the total amount of RAM that could be used on that agent, just to avoid cases when your load generator is just hanged and you cannot do anything, even SSH on there. And the current issues, so the current like limitations of the plugin. So right now, still, it is like using a lot of memory for establishing these connections in a sync controller. So we have two errors, not even errors. There are more. Actually, you can go to issues on their Git and check all of them. But also here, first one is to calculate async controller processing time. So we don't need to use that Groovy workaround that I showed you. And another one is this major performance blocker. Is do not establish connection with many parallel threads in controller. So try to start it with only one thread if possible. So it's kind of open issues. They should be addressed. And yeah, so it's finally the last slide. So if you have any questions, you can ask them. So Roman has a question. What about probability? Do you use switch weight controls, throughput controls? No, I haven't used it, but so as it is as HTTP2 plugin inherits the regular, like the HTTP base sampler, it is able to work with any controllers like logic controllers, preprocessor, post-processors, config elements, everything. So it should not be a big deal. If you will but again, as you see, you need to validate. Again, validate and verify that it works properly. If something is wrong, really feel free to, or you face any other issues that I was not mentioned. So actually, I mentioned only the major ones. But still, if you face any other issues, just go to their Git and create an issue and hope it will be fixed someday. Or at least David can provide some kind of workaround, maybe, for that. Any other questions other than that? Okay, so if there is no question, that I hope it was useful, and it will be even useful for me because if I'll need to run these tests again on some new project in half a year or year, because of all these details, they are not kind of documented anywhere. It will be really helpful kind of to recap what is going on and how to deal with all this stuff. Yeah, so thank you for the attention, and see you on the next streams. By the way, the next one probably will be with what's called with the interview. So we'll got some person like interviewee, or how it's called, yeah, interview, and several interviewers, and the candidate actually will be not the junior or middle. It will be the senior, at least senior plus guy. So we can ask trivial questions and also some interesting questions regarding different technologies, approaches, and all this stuff. So it also might be pretty interesting. So see you there. I'll post all the updates both in LinkedIn and in Perforator Club. So join there if you haven't done so. Okay. Have a good day and goodbye.